Well, with that introduction, kind of an overview of the mineral composition of soils, we need to next examine how these individual minerals in the soil are formed and what some of these minerals are. The properties of a particular mineral in the soil depend upon two basic things. Those properties, or those two basic things that influence their properties, are chemical composition and spatial arrangement. If we look first at chemical composition is saying what elements and in what proportions are those elements found in a particular mineral structure. In other words, what is the amount of oxygen there? What is the amount of silicon, aluminum? What amount of other cations are included in that structure? That's the chemical composition of that particular mineral. Many minerals have a very similar chemical composition, yet are quite different in terms of their ability to either resist or not resist breakdown and weathering in the soil environment. And the thing that makes the primary difference between the degree or resistance to weathering or lack of resistance to weathering is more so the spatial arrangement. So we're talking about chemical composition on one side, and on the other side we're talking about spatial arrangement. So spatial arrangement is really kind of, we can think of that as being the physical form that these elements are combined in. How are these individual elements arranged within that mineral structure? That's what we mean by spatial arrangement. Well, if we concentrate first of all on the chemical composition, I think there might be some surprises in here for a number of us. Which element or which elements are found in highest quantity in the mineral matter in the soil? Well, without exception, all minerals contain a very, very high content of one certain type of element. And if you haven't guessed this by now, or if you haven't picked up on this by reading through the reading assignment for this particular unit, the element that comprises the vast majority of both the weight and the volume of all mineral matter in the soil is the element oxygen. Although we have in excess of 100 different elements that are found in the Earth's environment, there are really only 8 of these that are very high in abundance in the mineral matter in the soil. The first of those elements is, as I mentioned, is oxygen. Oxygen comprises approximately 93.8% of the volume of the mineral matter in the soil and about 46.6% of the weight. This volume figure is actually less important than the percent by weight over here. This is a better representation. So we're saying that nearly 50% of all of the weight of minerals in the soil is the element oxygen. Now this is where we get involved in a little bit of chemistry, because when we think of oxygen, most often people think of the oxygen that we breathe and require for the life-sustaining process of respiration. However, this is not the same type of oxygen. If we're talking about the oxygen necessary for both plant growth as well as animals' respiration, that oxygen is O subscript 2. It is molecular oxygen. It is oxygen. Physical state is a gas. The type of oxygen that we're talking about in mineral matter is a solid mineral particle. That is to say that it is an oxygen anion. That means it has a negative charge, and it is an O with a superscript of -2. So we're talking about the solid mineral particle of oxygen in contrast to O subscript 2, which is oxygen gas, which most of us, I think, are familiar with. So oxygen is by far the most abundant element in the mineral matter in the soil. However, we should also realize that this type of oxygen is not going to ever become available and taken up and utilized by plants for growth. So almost 50% of the weight of the mineral matter is comprised of an element which is not something that plants need or can utilize directly from mineral matter in the soil for growth and development. The second most abundant element in the mineral matter in the soil is silicon. 27.7% by weight of soil minerals is silicon. This element is also not an essential plant nutrient. So now when we add those two together, we're talking about somewhere in excess of 74% of the weight of the mineral matter in the soil, when we add oxygen and silicon together, that is basically pretty much useless from a standpoint of plant nutrition. I'm not saying that it's useless from a standpoint of mineral composition in soils, because obviously it forms a very large framework structure, included inside of which are these other somewhat essential nutrients. The third element is aluminum. Third most abundant, 8.1% by weight. Like the first two, also not required by plants for growth.